Welcome to Epic, the channel where ancient mysteries come alive. Today, we're diving into 5 ancient mysteries that have baffled scientists for decades. Get ready to explore the secrets the past still refuses to give up. Dendur Light. Inside the Temple of Hathor at Dendera, Egypt, lies a set of carvings that have sparked decades of debate. Among the many symbolic reliefs, one image stands out, a bulb-shaped object with a snake-like figure inside, connected to what looks like a power source or insulator. Several figures surround it, seemingly interacting with the object. To conventional Egyptologists, the relief represents a common mythological scene, Harsamtus, the serpent god, emerging from a lotus flower, with the bulb symbolizing creation, energy, or cosmic rebirth. The structure beneath is interpreted as a jed pillar, a symbol of stability associated with Osiris. In this view, the scene is purely symbolic. However, alternative interpretations offer a radically different view. Some researchers, engineers, and authors have suggested that the carving resembles an electric light bulb, specifically an early vacuum tube or Crookes tube. The serpent inside is interpreted as a filament or electrical arc. The cable-like lines and positioning of human figures have been likened to a depiction of energy being harnessed. Supporters of this theory point to the absence of soot in deep Egyptian tombs, arguing that oil lamps should have left residue. They propose the use of some form of electric lighting for interior illumination, potentially using technology now lost to time. However, no physical evidence, such as wires, power sources, or light-emitting devices, has ever been found in association with the temple or other sites. Critics of the electric light hypothesis argue that the carving has been taken out of cultural context and misinterpreted. The temple is filled with layered symbolic language and religious motifs, and no ancient texts describe electrical concepts. Furthermore, Egyptologists note that the figures, positioning, and structure of the scene are consistent with other mythological narratives throughout Egyptian temples. The carving appears in a secluded, underground chamber, which has fueled speculation about secret rituals or hidden knowledge. But again, no corroborating evidence has surfaced. While experimental reconstructions of the device have been made using glass, electrodes, and gas mixtures to simulate the Crookes tube idea, these remain speculative and unsupported by archaeological data. In the end, the Dendur Light remains a subject of interpretation. To mainstream scholars, it's a religious symbol. To others, it hints at a lost understanding of energy or science. With no conclusive evidence on either side, the image continues to sit between symbolism and speculation. The Baghdad Battery. In the 1930s, near Baghdad, Iraq, a curious object was uncovered during an archaeological excavation. The artifact consisted of a clay jar about 13 centimeters tall, inside of which was a copper cylinder, and within that, an iron rod. The entire assembly was sealed with asphalt. In 1938, Wilhelm Koenig, then director of the Baghdad Museum, proposed a controversial idea. The jar was a type of galvanic cell, or primitive battery, capable of producing electricity if filled with an acidic liquid like vinegar or lemon juice. The configuration matched the basic components of a battery: 2 metals and an electrolyte. Subsequent experiments with replicas of the jar confirmed that it could generate a small voltage, around 0.5 to 1 volt. This led to theories that ancient people may have used such devices for electroplating, coating objects with a thin layer of metal like gold or silver. Others speculated it might have been used in medical therapy or religious rituals involving mild electric shocks. However, mainstream archaeologists remain skeptical. There is no physical or textual evidence from ancient Mesopotamia that suggests knowledge of electricity or electrochemical processes. Moreover, no electroplated artifacts from the relevant era have been conclusively linked to such a device. An alternative explanation is that the object had a non-electrical purpose. It may have been a scroll holder or a ritual object that was mistakenly interpreted as a battery. The materials used, clay, copper, iron, were all common in the region at the time, and their arrangement could have had symbolic or practical uses unrelated to energy production. Critics also point out that, although the jar can function as a battery in a controlled setting, it is highly inefficient and unstable. There is no evidence that multiple jars were connected in series to power larger devices, nor any sign of infrastructure that could support consistent electrical use. Despite this, the Baghdad Battery remains popular in alternative history circles as a possible example of lost ancient technology. Its enduring intrigue stems not from what it definitively proves, but from the possibility it represents, a technological anomaly that challenges assumptions about ancient knowledge. To most scientists, it is likely a misinterpreted artifact. But as long as questions about its true function remain unanswered, it will continue to stand at the intersection of mystery, science, and speculation. Damascus Steel. For centuries, Damascus steel was famed for its strength, flexibility, and sharpness. Used primarily in blades from the Near East between the 3rd and 17th centuries, it was known not only for its performance but also for its distinctive wavy surface patterns, often described as watery or ladder-like. Blades made from Damascus steel could allegedly cut through lesser swords or even rock without losing their edge. European crusaders were astonished by their quality, and the metal gained legendary status across cultures. Despite its reputation, the exact method of producing true Damascus steel was lost by the 18th century. Modern metallurgists have attempted to recreate it, but reproductions rarely match the original's properties or appearance precisely. The steel was believed to have been made from wood steel, imported from India and Sri Lanka. Wood steel contained high carbon content and was produced in crucibles, allowing for a unique internal structure. When forged and cooled properly, it formed carbide banding, which gave the blades both hardness and flexibility, crucial traits for superior weaponry. What made Damascus steel unique was not just the raw material but the forging process, likely involving strict temperature control, specific forging and folding sequences. Modern analyses of surviving blades using electron microscopy have revealed nanostructures, including carbon nanotubes and cementite formations, which may have contributed to the blade's extraordinary performance. These structures were not intentionally engineered but were likely the result of skillful control over the forging environment, without modern scientific understanding. Efforts to reproduce Damascus steel today often result in pattern-welded steel, where layers of different metals are forge-welded and etched to mimic the original's appearance. While these modern blades can be strong and beautiful, they are chemically and structurally different from true historical Damascus steel. The loss of the original process underscores the fragility of technological knowledge, especially when it is not written down or widely shared. Despite today's advanced metallurgy, we still cannot fully replicate the exact qualities of blades made hundreds of years ago by artisans working with simple tools and empirical techniques. Whether it was superior material science, blacksmithing genius, or a combination of both, Damascus steel remains a symbol of lost craftsmanship, one that still challenges modern understanding of ancient technology. Roman concrete. Many ancient Roman structures, from aqueducts to temples, have stood for over 2,000 years. Their resilience often surpasses that of modern buildings. The secret behind this longevity lies in Roman concrete, a material whose formula continues to fascinate scientists and engineers. Known as opus cementitium, Roman concrete was composed of lime, calcium oxide, volcanic ash, pozzolana, and rubble or stones. Unlike modern Portland cement, which often deteriorates over decades, Roman concrete seems to grow stronger over time. One key to its durability is the chemical reaction between volcanic ash and lime. When seawater seeps into the concrete, it triggers the formation of rare crystalline compounds like aluminum tobermarite and philipsite. These minerals help fill cracks and reinforce the material, giving Roman marine structures the ability to self-heal over centuries. This self-healing property is most evident in Roman harbor constructions, such as the breakwaters of Portus Cosenus, which remain intact despite continuous exposure to seawater for nearly 2,000 years. The Pantheon, with the largest unreinforced concrete dome in the world, is another iconic example. Modern scientists have analyzed samples of ancient concrete under microscopes, revealing this unique internal structure. While modern concrete depends on steel reinforcements, vulnerable to corrosion, Roman concrete achieves its strength without any metal supports. Despite many attempts, the exact replication of Roman concrete remains elusive. The materials were highly regional, and the process likely relied on empirical knowledge passed down orally. Recent studies suggest that Roman builders may have deliberately included unreacted lime clasts, which acted as hotspots for healing when cracks formed. Beyond its technical interest, Roman concrete raises broader questions. How did ancient builders develop such a robust material? Why was this knowledge lost for over a millennium? And can its principles be adapted to address today's construction challenges and environmental concerns? Indeed, modern cement production is a major contributor to global CO2 emissions. Roman methods, which use less energy and resulted in longer-lasting structures, may offer a more sustainable alternative, if their full potential can be unlocked. Roman concrete is more than a building material. It is a symbol of forgotten ingenuity, a construction technique far ahead of its time, and a reminder that the ancient world may still hold answers to modern problems. The London Hammer. Discovered in 1936 near London, Texas, the London hammer is a simple tool with a complex controversy. While hiking, Max and Emma Hahn came across a rock with a piece of wood protruding from it. Years later, when the rock was broken open, it revealed a hammerhead made of iron with part of a wooden handle, seemingly encased in ancient stone. What made this find unusual was the claim that the surrounding rock might be as old as 100 million years, based on its appearance and composition. If true, this would place a human-made tool inside a geological layer long predating human existence. Supporters of this idea argue that the hammer is an example of an out-of-place artifact, OP art, evidence that challenges mainstream historical timelines. They point to the purity of the iron, reportedly 96%, and the lack of rust on the hammerhead as signs of advanced or unknown ancient metallurgy. However, most geologists and archaeologists offer a different interpretation. The rock encasing the hammer is likely a concretion, a type of sedimentary formation that can develop over decades or centuries, not necessarily millions of years. It forms when minerals and water solidify around an object, gradually hardening into stone-like material. In this view, the hammer may be a 19th-century mining tool, possibly left behind by early settlers or workers, later encased by natural mineral deposits. The partial petrification of the wooden handle could have occurred under certain conditions, further contributing to the artifact's mystique. Critics also note that no archaeological context, such as ancient tools, dwellings, or other artifacts, has been found in association with the hammer. Its discovery location was not part of a controlled excavation, and there's no verifiable geological analysis linking the object conclusively to the claimed age of the rock. The hammer's composition, high-purity iron with some chlorine and sulfur, is unusual but not impossible for known historical smelting techniques. The absence of rust could be explained by the anaerobic environment inside the concretion. Despite these explanations, the London hammer remains popular in alternative history circles, often cited as possible evidence of a lost advanced civilization or even a pre-human technological culture. However, without supporting evidence or context, such claims remain speculative. For mainstream science, the London hammer is likely a case of misinterpretation rather than mystery. Yet the object continues to provoke curiosity, reminding us how easily everyday items, when placed in unusual circumstances, can spark profound questions about the past.